Hi, my name is Li Wei Ming. I am the manager for startups and small and medium enterprises divisions from Selangor Information Technology and Digital Economic Corporations, in short, SEDEC. SEDEC is a state government agency mandated to spearheading the digitalizations and the net zero for all our entrepreneurs within Malaysia. Selangor is the highest economic contributors to the Malaysia's, accounting 25.5% GDP contributions last year in 2023. While Selangor is striking for the economy, we also take account of a steady foundation for sustainable and long-term state development. We developed a Rancangan Selangor 1, or RS1 in short, a comprehensive development plan to charter the strategic direction of the state over the next 5 years with 261 initiatives. By participating in the Green Tech Startup Challenge, we hope that we can leverage on your expertise to digitize the waste management environment data on cloud using the IoT sensors to one of our food waste solution provider, Entoma. Selangor generates 15,000 tons of food waste daily, with a significant portion ending up in the landfill. A green tech startup in Selangor specializing converting the cooked food waste using a black soldier flies larvae to create valuable resources and in currently addressing the Selangor Municipal Food Waste Challenge in collaborating with a conglomerates in Subang Jaya, namely EMBC. State government Selangor wish that the EMBC solutions can benefit from the Taiwan Green Tech Startup Challenge with their expertise and technology to eventually post benefit from the Busan Malaysia Voluntary Carbon Mechanism for the longest sustainable advancement.
Hi, my name is Yani. I'm the co-founder and chief commercial officer of Entomal Biotech. Today, it is with great pleasure that we get to share with you problem statements that we get to do a pilot project together. So, with the use of black soldier fly, let's discover how the solution works. So, in just 7 days, all we need is a spoonful of the baby larvae to turn 1 ton of food waste into 2 valuable resources, namely the high-protein animal feed and a nutrient-rich fertilizers. And here's the exciting part, not only are we turning waste to wealth, we're also effectively reducing 96% of the carbon emission. So with this solution, we're killing 3 birds with 1 stone. With first, being a sustainable food waste solution for our local councils and private sectors. Second, significantly achieving a carbon reduction. And third of all, achieving resource recovery and a circular economy for our nation. So let's dig into the process. First of all, waste will come in from different kitchen sources. We'll do some pre-processing with the grinding process as well as adding in certain secret recipes. And from there, food waste will be introduced into the baby larvae. And just wait for the 7 days, they will be fully matured, where 2 products are harvested using a sieving machine and eventually being packed separately to be sold as animal feed or organic fertilizers. With that, we've come up with 2 approaches. First, a decentralized container to treat waste at source, and second, a centralized biowaste conversion plant to treat large volumes of waste. Housed in a shipping container is what we call as the EMBC, Entomal Mobile Bioconversion System. Treating up to a ton of food waste per month, it's viable for places like communities, hotels, schools, and also corporate buildings. Clients will be paying us on a monthly subscription basis and eventually getting carbon reports in order to fulfill with their ESG compliance goals. Fun fact, this is a solution that has received the TIE award from Taiwan Innotech Expo in 2023. As we see in the photo, this is the whole process. There are blue drums where food waste is collected and delivered on a scheduled basis. Then the food waste is grinded and eventually being placed into the trays for the rearing process. 7 days later, operators will come in to do the sieving and eventually pack separately for products to be sold. With the EMBC solution, we're able to treat waste at source. Currently, this solution is in operation at Sunway Lagoon, Taylor's University, Le Méridien Hotel, MBSA, with upcoming units in Courtyard by Marriott as well as YWCA. For this pilot project, we will be working on the EMBC at Sunway Lagoon, Malaysia that has been fully operational in the past few months. It's currently treating up to 1.2 tons of food waste every single month. And now let's discover all the interesting facts about our testing field at Sunway Lagoon. So currently the facility is standing at 22 times 8.4 feet with electricity supply. Every Monday and Thursday, 4 operators will be on site, 2 from Sunway side and 2 from our side. They'll be working there for 3 to 4 hours, mainly to do the food waste grinding and then feed the baby larvae with our food waste and eventually doing the harvesting using the sieving machine. So basically on site, there will be 2 machines in use. One is the food waste grinder and secondly, the sieving machine. We have also attached some photos for your reference. So this is the whole setup currently. The brown board is basically where our current IoT system is installed. There are 4 main data that we collect with the current IoT dashboard, namely the ammonia levels, temperature, humidity levels, as well as the carbon dioxide that's emitted within the premise. Currently, we also have a total data dashboard that requires some manually keyed in data. So currently, we will require information based on the fresh waste weight, the grinded waste weight, and then from there, putting in how much larvae and eventually 7 days later, how much output of larvae and frass are there. With those information, our team will also do a calculation with the formula. First of all, looking at the carbon emission emitted within EMBC or through the treatment of EMBC. Also looking at the same amount of food waste if it was sent to landfill, how much carbon emissions being produced. And from there, we do a deduction to calculate emission prevented. And then we also look at trees that are needed for EMBC with the amount of carbon emission that's being produced, compare it with the ones that are sent to landfills, and from there calculate how many trees we're saving, using it as a great metaphor for people to understand. And lastly, we also want to look at, with this kind of sustainable waste management, how much temperature are we helping to reduce? So as a summary, some of the current issues and challenges we're facing consist of identifying better or even more suitable IoT sensors for us to have a more comprehensive data collection, and also helping us to streamline the whole data management process, because right now our team still have to manually weigh and key in all this data based on the weight that is being put in or processed. And also if there are any existing kind of carbon exchange or carbon calculation mechanisms, we would also like to learn more about as well. The ultimate objectives of this pilot is to really help our EMBC of obtaining real-time data, as currently a lot of this are not real-time. And second of all, since we will be rolling out more EMBCs across Malaysia, we're looking into automating all this data collection as well, as compared to the now manually done ones. And third of all, also to look at the value of these data, because ultimately our goal is to be able to trade our carbon credits on Bursa Carbon Exchange, or potentially in the future on a global scale as well. So all this data will be very valuable for the progression of the carbon credits. So here are some of the expected outcomes that we have. First of all, looking into implementing IoT sensors for real-time monitoring of all this important data. Second of all, looking of using cloud integration for a streamlined automated data management. And third of all, strengthen our collaboration with Malaysia's Bursa voluntary carbon mechanism, and basically collecting valuable and reliable carbon data to eventually be used for carbon crediting. And most importantly, in the fourth one, is looking at the scalability and also the cost effectiveness of having these IoT sensors for all our EMBCs that's being rolled out later on.